If you're new to ComfyUI and AI image generation, you might be confused by all the different nodes and parameters that you see in the ComfyUI workflow. Today I'm going to try and decipher the most commonly used nodes and parameters and hopefully make you understand their role and what effect do they have on the resulting image. Let's dive into it. So in here I have the workflow that I've used in the previous video. Now let's break down each of the nodes in the workflow and their parameters and see what they actually do. First we have the checkpoint loader nodes for the base and refiner models. These simply load your checkpoint file that you select here. They can also provide their own clip and VAE models, which they are doing in this example, but we will talk about those later. Now as you can see we have two checkpoint loaders, one for the base model and one for the refiner. This isn't going to always be the case, and in some workflows you will have only one checkpoint loader for the base model. The refiner model is optional, but if you use it you will be able to generate higher quality images with more detail and clarity. Next we have the text prompts. This is where you put your prompt to generate the image from. You have the positive prompt, which is a description of the image that you want to generate, and you tell the generator what the image should contain. And then you also have a negative prompt, where you type in some keywords or features that should not be in the image. You can also see these text and code nodes for the base and refiner prompts. These will always contain the prompt that you were writing in a text prompt node, and these are read-only and you cannot really modify them in any way, so you can safely just ignore them. You can actually make two separate text prompts, one for the base model and one for the refiner, but this is usually not needed, and it should only be done if you want to use the refiner to try and make some details of the image a higher quality. Next is the load LoRa node, which is optional and is used for loading a LoRa if you have one. You will have to select your LoRa in this drop-down list here, just like with the checkpoints, and the model will take model and clip inputs from the base model, and it will output the clip into the text encode nodes, and the model into the K-sampler. There are two parameters here, which is strength model and strength clip. Strength model is the LoRa strength or weight, and setting it to higher values will force the image to look closer to the LoRa. So if you have a style LoRa, it will look closer to that style, or if your LoRa is a person, then the person in the generated image will look closer to the person your LoRa is trained on. This parameter should typically be set to between 0.5 and 1.0, but can go higher and lower than that, and you can even set it to a negative value if you actually want to remove a style or feature of the LoRa from the image. The clip strength means that if your LoRa was trained with captions or trigger words, and you have a keyword in your prompt that corresponds to a caption, then setting the strength clip to higher values means the image will be more sensitive to those keywords and try to make them look closer to images that were captioned with the same word or phrase. Generally, the clip strength is less important than the model strength, and usually they should both be at the same value. Now let's look at the K-sampler node. The K-sampler is the most important and perhaps the most complicated node, and can be seen as the heart or the CPU of the workflow. It takes some inputs from the other nodes that I described previously, and has some parameters that you can change. Let's go over them. Before I begin explaining the parameters, we also have to understand that there are actually two types of K-sampler. There is the basic K-sampler, which is this one, and there is the advanced one, which is this one, and they have some key differences. You will need an advanced K-sampler if your workflow is using the refiner model in addition to the base one. The most notable difference between the two is the steps parameter. Steps is the number of iterations that the sampler performs to remove noise from the image. Essentially, the more steps you have, the more accurate your image will be to the prompt, and the quality of the image will be higher. However, the image will take more time to generate. Generally, the number of steps should be between 20 to 40, but different checkpoints have different recommended values for the steps. In the basic K-sampler it's easy, just set the desired number of steps. In the advanced K-sampler it's more complicated. You see, when you have a refiner model in your workflow, you should have two advanced K-samplers, one for the base model and one for the refiner. And as for the steps parameter, first you have the total steps number, like in the basic K-sampler. Here it actually has its own separate node. Then you have the started step parameter. For the base model's K-sampler, it will always be set to 0. This is simply the step number where the K-sampler begins its work, and the base K-sampler always works before the refiner one, so it should always start at 0. Then you have ended step. Again, this is a separate node here, and this is the step number when the base model K-sampler will stop the denoising process, and the refiner K-sampler will pick up. The reason why steps and ended steps are their own separate nodes in this workflow is so that you can take this value and then connect it to the refiner K-sampler, which is more convenient because the number of steps will be the same as in the base K-sampler, and the started step parameter will always be the same as the base K-sampler's ended step. So ended step goes into here, and from here it will go to started step here. So in this workflow, in the refiner case sampler, there is only one step parameter that you can modify, which is end at step. And you can see that end at step is set to 10,000. Why is that? Well, the end at step value cannot go higher than the total step number, but if you do set it to a higher number like we have here, it will simply stop at the total steps number, which is in this case 50. So whether you set it to 10,000 or 50, the effect will be the same. Essentially, setting it to a very high number is the equivalent of telling it to run until reaching the end of the total step count. You could also take the steps node and connect it to the ended step of the refiner case sampler, and it will be the same thing. It's just a matter of what you think is a cleaner workflow design. The next parameter is CFG. CFG, or classifier free guidance, is a value that will determine how closely the generated image will match your prompt. Simply put, lower values of CFG like 1 to 5 will give the model more creativity with the image, while higher values like 10 to 20 will make the image strictly follow the prompt. With the CFG and many other parameters, I find it's best to check the recommended settings for your checkpoint. Next we have the sampler and scheduler, where you can choose many different values, or more correctly algorithms, from a drop-down list. The sampler is the algorithm used for the denoising process, and the most common algorithms used here are Euler, DPM++2M, or DPMM++STE. In some samplers like the DPMM++STE, you can also see a variant suffixed to GPU. If you choose this variant, it will mean that part of the calculation that's used in the algorithm will be offloaded to the GPU rather than being used by the CPU, and generally you want to use this variant rather than the non-GPU one because it is faster. Now, we've talked about the number of steps used in generating the image, but we can also change the step size by choosing different schedulers. The scheduler you choose can change the number of steps required to generate a good looking image, and can generally change image quality. For example, the Keras scheduler will generally give you better image quality and is a very common choice, while the exponential scheduler could generate your image more quickly, but could also lower the quality. Again guys, like with the other parameters, the checkpoints you download should generally have a recommended scheduler and sampler that you should be using. One very interesting parameter here is the seed. The image seed is kind of like a unique ID of a generated image, and is a very large random number, and different seeds will always give you different images. If you've ever played Minecraft, you know that every world has its own seed, and you can choose a seed when creating a new world, and you can use other people's seeds if you want your world to be exactly the same as theirs. Well, it is the same here but with images. If you generate two images with the same seed and the same parameters, it will literally be the exact same image. The seed is actually a very useful parameter that you can use to test how the other parameters work. Simply set control after generate to fixed, and generate one image. The next images generated after that one will always use the same seed, and you can change the other parameters we've talked about, like the sampler or CFG, or the steps number, to see the effect they have on the image, allowing you to understand them better. Because the images use the same seed, the only difference between them will be the different values that you've set in the parameters. So if you want to see how your image will look like with more or less steps, for example, you can just change this parameter, keep the same seed, and you will see exactly what the steps number does to your image. The other two parameters, which are only found in the advanced case samplers, are add noise and return with leftover noise. And those have to do with the fact that we're chaining two case samplers here and using the refiner case sampler to pick up the generation process when the base case sampler stops. You can pretty much ignore those. The base case sampler will always have them set to enabled, and the refiner case sampler always has them disabled. That's pretty much all you have to know. Next is the empty latent image node. This is simply the resolution of the output image. Different checkpoints and base models will have different recommended resolutions that you should use, and you should generally follow those recommendations. You also have the batch size here, which is the amount of images generated, but you can also set the batch size here next to the run button. Lastly, we have two nodes that you will not see in every workflow because they're also integrated into the checkpoint loader node, but sometimes it might be useful to have them as a separate node. Those are the load VAE node and the dual clip loader. I won't dive too deep into the technical details of those, but essentially when it comes to the VAE node, you might want to add it as a separate node and select a VAE file from the drop-down list, and this could improve your image quality. The clip will usually come from the checkpoint, like it does here, but sometimes you will see it as a separate node. The last thing I want to mention is you can also disable or bypass a node that you don't want to be used in the image generation process. For example, we can disable the slower loader node by bypassing it. When you bypass a node, you don't actually have to move around any of the connections of that node, the inputs and outputs. They will simply go through the node and ignore it. That is the end, guys. Hopefully my explanation was clear to you. For the most part, I try to keep it practical and avoid technical details that you don't need, I did use some technical terms in this video, but you don't need to worry about it really. For now I'm out, and I'll see you in the next video.